Can Euclid's formula find all Pythagorean triples in geometry? Have you ever wondered if there is a formula that can help you find all Pythagorean triples in geometry? Well, let's break it down together. Pythagorean triples are sets of three positive integers that satisfy the equation where the square of one side plus the square of another side equals the square of the hypotenuse. This is known as the Pythagorean theorem. Euclid's formula is a well-known method to generate these triples. It uses two positive integers, which we will call m and n, where m is greater than n. The formula defines the triple as follows. The first number, a, is calculated as m squared minus n squared. The second number, b, is calculated as 2 times m times, and the third number, c, is calculated as m squared plus n squared. When you apply this formula, you will always end up with a Pythagorean triple. This is because when you square a and b and add them together, the result will equal c squared. You can confirm this by expanding and simplifying the expressions. However, it is important to note that Euclid's formula generates what are called primitive Pythagorean triples. These are triples where the three numbers do not share any common divisor other than 1. For example, the triple 3, 4, 5 is a primitive Pythagorean triple. Now, all non-primitive triples, which are simply multiples of these primitive ones, can be obtained by multiplying the primitive triples by a whole number. This means that while Euclid's formula can generate all primitive Pythagorean triples, you can also create all Pythagorean triples by scaling these primitive ones. To clarify further, every primitive Pythagorean triple can be generated by Euclid's formula using pairs of integers m and n that meet specific conditions. These conditions include being coprime, meaning they have no common factors other than 1, and not both being odd. So, in essence, Euclid's formula is a powerful tool that can find all primitive Pythagorean triples. By scaling these, you can generate every Pythagorean triple. This makes it a fundamental concept in understanding right triangles and their side lengths in geometry. In practical terms, Pythagorean triples have many applications. They are used in fields like architecture, carpentry, and engineering, where creating precise right angles is essential. By using Euclid's formula, you can generate triples to measure or build right-angled structures without needing complicated measuring tools. This method connects basic number properties to the geometry of right triangles, making it easier to see how shapes and numbers relate in geometry. So, if you are looking to understand Pythagorean triples better, Euclid's formula is a great place to start.